Hi everybody. Our first lesson for the year is on trigonometry, and on page 3 of Sadler's text it has a little situation. It's an introduction to the topic, and each chapter typically has one. In this case we have a person sitting on a boat. The boat is 2 meters above sea level, and to the top of the lighthouse is 16 degrees. So effectively we are here. Another 50 meters away, the angle is decreased to 12 degrees. So the boat travels 50 meters away from the lighthouse, and now the angle is 12 degrees to the top of the lighthouse. This is the lighthouse here. Now we want to know how high the lighthouse is above sea level. And if we have a look, we haven't actually been given enough information to solve any one of the triangles given, but we can form what's similar to a simultaneous equation and then solve it that way. So here we go. If you haven't had a go at this yet, it's probably best to stop the video, take a pencil and have a go at it, and then restart it once you've figured it out to make sure that you're correct. But if you have no idea what to do now, which would be fine because we haven't done the topic yet, you can just watch the way through. So if we know that from here to here is 50, and we know this total length is y, this length from here to here will be y minus 50, because y minus 50 plus 50 would give us y. And we can create a trig ratio from that. So cos 16 is tan 16 is opposite over adjacent, which would be x on y take 50, which is this expression here. We're trying to find x, but in this case what we're going to do is we're going to make y the subject, and I'll show you why in a second. That's a bit of a funny. So over here I've multiplied both sides by y take 50 divided both sides by tan 16, which gives you this expression here. Added 50 to both sides to give you this one, and so we know that y equals x on tan 16 plus 50. Over here we've done the same thing for this triangle here. So we know that tan 12 is x over y, which is this expression here, and rearranged it for y equals x over tan 12. Now the y's in both equations are the same, so if these are the same, the right hand side of each equation also has to be the same. So we can equate them together, which I've done here. And then to make my life easier, because this doesn't really resolve easily in exact values, I've plugged it into my calculator. There it is there. Gotten this expression here, solved that expression, and been told that x is 41.07. So that's from here to here is 41.07. Now remembering we're 2 meters above sea level in the boat, so we've got to add those 2 meters on to find the total height of the lighthouse, which would mean the lighthouse is 43.03 meters high. So although we didn't have enough information to solve either triangle, together we had enough information to solve it. Two equations, two unknowns, we can find an answer. If we wanted to find out y, we could have substituted 41.08 back into one of these two equations, and that would have found y for us. A couple of things to note. If you're using your calculator for trig ratios, make sure your calculator is in degrees mode. This will become more important later when we change that to a different mode. And if we're looking for a decimal answer, this should be decimal. If we're looking for an exact value, that should be standard. First part done. Now, I talked earlier about values for sine, cos, and tan. We found over here the value for tan 16. But if we type that into a calculator, we'll get a number out. Let's just do that. Where is it? Here. If I type in here tan 16, make sure my calculator is in degrees mode, I get 0.2867. But where does this number come from? Well, we can see it in two different places. One, we can see it on a tan curve, which I suppose I can bring up. Y equals tan x, and if I graph that, that should be okay. And we want that for it to go from I don't know, negative 100 to 100. Oops. Make sure this goes from 0 to 360. Actually, for tan we don't want that. We want it to go from negative 180 to 180. Let's see how that graphs. Here we go. So we end up with these two graphs here, and I might shorten that a little bit more, make it a bit more obvious. Okay, so here's a tan curve. Goes something like that. Now we can see here from negative 90 to 90. At 0, tan is 0. At negative 90, it goes off to negative infinity. But what is it when it's not resize? I want analysis, gsolve, xcal, ycal. Okay, so when it's what was I doing before? Tan 12. When it's 12, what's the corresponding y value? And we can see here we get that 0.2126 number. And if we go back to main, because I was supposed to be doing 16. Let's go do 16. Click, analysis, gsolve, xcal. Oops, I haven't got a graph yet. Graph the graph, analysis, gsolve, ycal 16. Lo and behold, we get that 0.2867. So we can see that that value that we got comes off the graph. We can also see it on a unit circle. And whereas we can't really get the graph without a graphics calculator, we can get the exact value graphically off a unit circle. So here is a circle, and in this case the angle is equal to 25 degrees. That's this angle here. And we know that tan x is equal to 0.466308. So if I had a look over here, 25, we'll find that there's that 0.4663 value, which is the same as this one here. Yeah. Now we know that for a unit circle, and the thing that makes it a unit circle is that the radius is 1. So that point there's going to be 1, this point here, this length here is going to be 1, this length here is going to be 1, this length here is going to be 1. And by putting it on a Cartesian plane, if the length of that's always going to be 1, when we go to this side, the horizontal length will be -1 and the vertical length down here will be -1. So if we consider that we're always going to measure the angle from the x-axis anti-clockwise, that angle there is going to be 25. If we want to know tan x, it would be opposite over adjacent. So opposite over adjacent. If we wanted to know cos x, it would be adjacent over hypotenuse. And if we wanted to use sin x, it would be opposite over hypotenuse. Now a nifty thing here is because this is 1, sine 25, sine of this angle here, will equal the opposite, which would be this value of y, divided by 1, which is the length of the radius. That simplifies down to not x. It's not quite right, is it? Let's fix that up. Let's make that y. y equals sine 25. So if we measured this height using a ruler, knowing that this length is 1, that height there is 0.423. And thus we can get all the sine values that we need by measuring lengths and angles on a unit circle, and then using our trig ratios. Now the question is, if it was a obtuse angle, like I don't know, what's 180 take 25? 165? 155. 155. We'd be looking for this angle here, and we're looking for the sine, cos, and tan of it. Well, we can see that this height here would still be y. And in fact, it's going to be a positive value of y. And if we're looking for the same solution in the first quadrant where we can use our trig ratios, we know that it's this angle here, which is 180 take our obtuse angle, which gives us our 25 degrees. So, if we want sine theta, it would be this length divided by 1, or just this length here, which would be 0.423, the exact same value that we get for sine 25. So sine 155 is the same as sine 25. For cos, we have to be a little bit careful, because the horizontal length here is going to be a negative value. Negative value divided by 1 would be the negative of what we found in the first quadrant. So the length of x here is going to be negative of what cos 25 was. And this property is true for all values between 90 and 180. So sine of the obtuse angle is equal to sine of 120 take the acute angle. For sine, and for cos, it's the negative of the acute angle is the cosine value for the obtuse angle. We can see this for sine curves. So let me just put a sine curve up here. Now, let's have a look. We want to change this a little bit. Make this from -1 to 1. And maybe to make our life easier, we'll go from 0 to 360. So if we look at a sine curve between, I'll go back a bit further. Okay, so if we go from 0 to C360, the values for sine between 0 and 180 are all positive. If we did it for cosine, we can see that the values from 0 to 90 are positive, but the values from 90 to 180 are negative. Remembering that these values here are what we're trying to get off the unit circle. Now, we can look at our case of 155. So if I click on this here, go analysis, gsolve, ycal. Yep, choose that one, please. 155. That will give me my 0.4226, as we'd expect. So that's the value for 155. We can see that it's 0.4226 as we expect. If we look at 25, we'll find out that it's also 0.4226. They're equivalent. And for cosine, if we did the same thing, oh, used the wrong one, haven't I? Try again. Don't want that one, we want that one. It's the cosine curve. And we want it for 25 degrees. We find that it's 9063. So very close to 1. If we looked at 155, want the other curve, please. We'll find that the answer is now negative. There it is down there. And the same value, 0.906. Now it's really useful to know what these two curves look like, sine and cosine, and it's also useful to understand this property of 180 take x equals x, and whether it's negative or positive. Now once you've done that, though this sounds a little bit confusing, and it usually is the first time, when you do the exercise it'll all become quite obvious. So now do exercise 1A. Thank you everyone.